Right, this is PreCalc 1C Toolkit Functions.
The first parent function we have here is a linear function, which the equation for is y equals x. The symmetry of this function is odd, meaning that it is symmetric with respect to the origin of the graph. It is also unbounded, so it has no minimum or maximum value for the entire function. There are no vertical or horizontal asymptotes, and the function is continuous at all x, so there are also no discontinuities.
The domain of the function y equals x is negative infinity, infinity, and the range is also negative infinity, infinity. This is because the line has no asymptotes and is continuous forever. This function increases from negative infinity to infinity because it is a linear function with a positive slope, meaning it will increase forever. The graph has no extrema because it increases continuously. The limit of f of x is infinity as x approaches infinity, and the negative infinity as x approaches infinity.
The next function we had was a quadratic. Its equation is y equals x squared. The symmetry is even because it is equal across the y-axis. It is bounded below because it never goes below the point 0, 0, and it has no asymptotes or discontinuities.
The domain for this function is negative infinity to positive infinity. The range is 0 to infinity. This function decreases from negative infinity to 0 and increases from 0 to infinity. It has an absolute minimum of 0 at 0. The limit of the function is infinity as x approaches infinity, and is infinity as x approaches negative infinity.
The next function we have is the cubic function. The parent function of this is f of x equals x cubed. The domain of this function is negative infinity to infinity, and the range is negative infinity to infinity. The symmetry is also odd.
It has no asymptotes and or discontinuities. It is increasing from negative infinity to positive infinity and has no extrema.
This is an inverse linear function, also known as a rational function. The parent equation is f of x is equal to 1 over x. The symmetry is odd and is not bounded. This function has two asymptotes, one being a horizontal asymptote at x equals 0 and a vertical asymptote at y equals 0. There is an infinite discontinuity at x equals 0, which is non-removable.
The function is decreasing from negative infinity to 0 and from 0 to positive infinity. There is no extrema, and the domain and range is from negative infinity to 0 and 0 to positive infinity, because they will never reach 0.
So the square root function does not have symmetry. It is bounded below. It has no vertical asymptote, horizontal asymptote, or any other discontinuities.
The square root function is increasing infinitely from 0 and has an absolute minimum of 0 at x equals 0. The domain is from 0 to infinity, and the range is from 0 to infinity.
This is the absolute value function. It is even in symmetry and is bounded below. There are no asymptotes and no discontinuities.
The function decreases from negative infinity to 0 and increases infinitely from 0. It has an absolute minimum of 0 at x equals to 0. The domain is from negative infinity to positive infinity, and the range is from 0 to positive infinity.
The first function we'll be talking about is the exponential function.
The exponential function for b is greater than 1. The parent function is y is equal to 2 to the power of x. There is no symmetry. It is bounded below. The horizontal asymptote is y equals 0. There is no discontinuity. For 2 to the power of x, the graph is increasing. There is no extrema. The domain is negative infinity to infinity, and range is 0 to infinity.
Exponential function y equals half to the power of x has the same properties as 2 to the power of x, except the function y is equal to the graph is decreasing on y equals half to the power of x.
The next function is log base 10 of x. It has the following characteristics, where it has no symmetry, no bounds, discontinuities, or extrema, a domain from 0 to positive infinity, and a range from negative infinity to positive infinity, a vertical asymptote at x equals 0, and no horizontal asymptote, and the function is increasing from 0 to positive infinity.
So this is the greatest integer function, and it can be represented 3 ways. Written, it will be the first one listed as y equals, and then 2 brackets with x in the middle, but it can also show up as int in parentheses x on the calculator, and on Desmos it will be floor and then x in parentheses.
The domain is negative infinity to positive infinity, and the range is all real integers.
The end behavior is x decreases as it reaches negative infinity and increases as it reaches positive infinity.
And there is no symmetry, extrema, asymptote, and it is not bounded.
The output is that the greatest integer is less than or equal to the output.
Alright, the parent function of the logistic function is f of x equals L over 1 plus e to the negative k times x minus x0, where L is the curve's maximum value, e is the natural logarithmic base, k is the steepness of the curve, and x0 is the x value of the curve's midpoint.
There's only symmetry if the midpoint is at 0, 0. Oh, the function is boundless, is bounded at y equals 1 and lower bounded at y equals 0. There's asymptotes at y equals 1 and y equals 0, and there's no point of discontinuity.
The function is always increasing and decreasing. There's no extremas. The domain is negative infinity to infinity, and the range is 0 to 1.
This is a sine function. It starts at the origin and has an odd symmetry.
It also is bounded on the top and bottom because a sine function never goes to the infinity or negative infinity on the y-axis.
This function doesn't have any asymptotes or discontinuities.
The extrema is there's an absolute max of 1 at x equals pi over 2 plus 2 pi k, and then, and then this is a cosine function. It starts 1 above the origin.
It also is bounded at the top and the bottom because a cosine function never goes to infinity on the y-axis.
This function also doesn't have any asymptotes or discontinuities and has an odd symmetry.
The extrema for a cosine function is again that sine equation, the same as the sines.